Hi, welcome to Expertizer Academy. This is Giri, lecturer in physics. In this video, we discuss about the production of induced EMF by using the orientation of the coil at magnetic field. This is the third method to produce the induced EMF in the magnetic field. First two methods discussed before video. In this video, we discuss about only third method to produce the induced EMF. Okay. So, what is the meaning of induced EMF? Induced EMF, it's nothing but the direction of induced EMF is opposite to the EMF which is produced in primary coil. So, induced, it's nothing but direction is opposite to the normal EMF. So, electromotive force or EMF, it's nothing but work against the charge. Work against the charge. Okay. There is a three methods to produce the induced EMF by using the or at the magnetic field. First two methods are completed before videos. This is the third method. That method is induction of EMF by changing the relative orientation of the coil with the magnetic field. Relative orientation of the magnetic field. Okay. Look at here. Consider these are the magnetic field lines. Here we introduce the coil. This magnetic field is B. Here these are the magnetic field lines. These field lines are moving this coil. The area of the coil is capital A. The magnetic flux generates here, that is phi, which is maximum, that is phi m. This is the rotation direction of the coil. So here omega represents angular velocity. Okay, this is the axis of rotation. Okay, here there is a small rotation here. This maximum flux is converts into two parts with respect to horizontal part, with respect to vertical part. Okay, this rotation makes the angle, that is theta is equal to omega t. Here phi m is converts into two parts, phi m cos omega t, phi m sin omega t, phi m cos omega t, phi m sin omega t. Okay, by using this horizontal and vertical parts of the flux, the horizontal part, that is equal to with respect to the or multiplication with the number of turns n into phi b, that is equal to n into phi m cos omega t. So this one represents the magnetic field in horizontal part. Okay, so this magnetic flux is changed with respect to the time. This flux is changing with respect to the time, that is dn phi b divided by dt, which is equal to induced EMF. This law represents the Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. So what is the Faraday's law of electromagnetic induction? the induced EMF must be equal to rate of change of flux. This induced EMF is opposite to the direction of the flux. So that's why here we are using the epsilon is equal to minus d phi by dt. But here n is the multiplying factor with phi b. So that phi b is equal to phi m cos omega t. So differentiate cos omega t, that gives minus sine omega t into omega. So phi is equal to n phi m omega sine omega t. Epsilon is equal to n phi m omega sine omega t. Okay. So here there is a different rotations or different orientations in the coil. This orientation is represented by the wave. See the first one. Here the orientation, I mean that angle is 0. The vertical part phi is equal to phi m sine 0 must be equal to 0. So why here choosing vertical part? We are taking sine wave. Sine, that value is minimum at 0 degrees. The wave is starts at minimum value. So that's why this is the sine wave. So for vertical part here, epsilon is equal to epsilon m sine 0 must be equal to 0. Coming to this one, the orientation is most perpendicular to this. So that's why here angle is 5 by 2. At 5 by 2 sine is maximum. So that's why this value is maximum. So this is the point of the maximum EMF. Okay. Coming to the third one, here the rotation is equal to pi value. So this one gives, this is the point of the EMF. Here the EMF is 0. Coming to this one, so another rotation gives 3 pi by 2. So here this value is the maximum but in opposite way. So this is the minus phi m. Coming to the here, 2 pi is the angle at the place of sine. So sine 2 pi must be equal to 0. Again, this EMF equal to 0. So this is the different orientations which is represented by using the sine wave. So here induced EMF equation epsilon is equal to n phi m omega sine omega t. Okay. Here if sine is maximum, look at this. If sine is maximum, here sine omega t is maximum. That means omega t must be equal to pi by 2. So this induced EMF is equal to maximum EMF. So maximum EMF n phi m omega. So we know that maximum flux that is equal to magnetic field into area of the conductor. We introduce that sigma m maximum induced EMF must be equal to nba omega. So therefore here epsilon is equal to EMF that is equal to epsilon m sine omega t. Okay. At the same time, induced current must be equal to maximum current into sine omega t. So in this video we discuss the third method to produce the EMF, that is induced EMF. So what happening here? Look once again. There is a conductor at magnetic field. This conductor is rotating with respect to the x and y axis, that means horizontal and vertical part. By using these parts, we have to use the Faraday's law of electromagnetic induction by using the change in flux. That flux is converting to n phi m cos omega t. After calculation part, epsilon is equal to n phi m omega sin omega t. You have to observe the different orientations of the coil in the magnetic field, and also you have to represent induced EMF and maximum EMF equation, and also induced current and maximum current. So this is the information about the third method to produce the induced EMF, that is orientation of the coil at magnetic field. So thanks for watching this video. For more videos, visit www.expertiseracademy.com. Thank you.